the next part of 4.1, let's talk about what we know about zeros of polynomial functions. Well, we know there can be rational zeros, and rational zeros are like 3, -5, 1/2, anything that can be written as a fraction is considered a rational zero. Then there are what are called irrational zeros. These will still cross the x-axis, but it won't be at a whole number or at an integer location. It could be something like the square root of 7 or -5 plus the square root of 2. Things like that are irrational zeros. We could also have complex zeros. Those are things like 5i or 8 minus 7i. All of those are complex zeros. And what we know and have learned is that irrational and complex zeros come in pairs. So if I tell you that 3i is a zero, then you also have to know that -3i has to be a zero. If 2 plus the square root of 5 is a zero, then so is 2 minus the square root of 5. If 8 plus 4i is a zero, then 8 minus 4i is also a zero. So in the next set of problems, they're going to give you some zeros, and they want to know, all right, if the degree is 4, what would be my other zeros? So if they were to give you problem 17, which is not one of the ones that you have to do, but if we look at 17, they tell me that -1 is a zero, the square root of 3 is a zero, and 11/3 is a zero, and it has degree 4. So that means I'm looking for 4 zeros. So here's one, here's another, here's another. Then the other one that I'm going to have is going to be, if square root of 3 is a zero, then so is the negative square root of 3. And now I have 4 zeros. Rational ones don't come in pairs. So the fact that I have -1 doesn't mean I'm going to have a +1. It doesn't happen like that. But the square root ones do come in pairs. So if you've got a square root of 3, you're going to have a negative square root of 3. 18, they tell me that negative square root of 2 is a zero, -1 is a zero, and 4/5 is a zero. So there's 3 of them. And my other one would have to be, if negative square root of 2 is a zero, then positive square root of 2 would have to be a zero. 19, they only give me 2 zeros, -i and 2 minus the square root of 5. Well, if -i is a zero, then positive I has to be a zero. So now I have 3. If 2 minus the square root of 5 is a zero, then so is 2 plus the square root of 5. And now I have 4. The next set of problems work the same way, except the degree is 5. So you've got to find enough so that you have 5 zeros. Okay, then they say, okay, if I give you some zeros, what's the lowest degree polynomial you could find? So like for problem 34, if I tell you you've got 2 minus I and -1 is 0, what's the least degree polynomial you can find and find it? Well, -1's great. It doesn't pair up with anything, but if I have 2 minus I, I'm going to also have to have 2 plus I. So I have to have at least a degree of 3 with these 3 zeros. So I've got to find that polynomial function. That'd be x minus 2 plus I. That's if you subtract this one. I'll do this one next. X minus 2 minus I and x plus 1. These would be my 3 factors. And then I would multiply them out like we did in that last video to find it. If I had problem 38 and I said, okay, 3 is a 0 and -i is a 0, what's the lowest degree polynomial function I can find? Well, if I have -i, then I have to have a positive I. So there's nothing else that I have to have. My factors will be x minus 3, x plus I, and x minus I. And I would just multiply these out to find my polynomial function. And that's how you do that next set of problems. All right, the next ones, they give you a polynomial function, and they give you a 0, and they want you to find the other zeros. And we're going to use our calculators to find the other zeros right now. We'll get into finding them a different way in a minute. They give me in 43 f of x equals x cubed plus 5x squared minus 2x minus 10, and they tell me that -5 is a 0. Okay, since this is cubed, I'm going to look and see if there are any zeros that I can easily find. There may not be. I'm going to go here, and in my y equals, I'm going to type in this function, clear this one out, x to the third power plus 5x squared minus 2x and minus 10. Alright, I'm going to check the table. They told me that negative 5 is a 0, which I see, and I don't see anything else in here. If I found other zeros, then I could list them, and maybe I'd have all the zeros that I need, but that only one that I see there is negative 5. So I'm going to come back over here. If negative 5 is a 0, I'm going to use synthetic division and divide that factor out. And so I have to write the coefficients of these terms, which would be 1x cubed, 5x squared, negative 2x, and negative 10. Bring down the 1. Negative 5 times 1 is negative 5. Add, you get 0. Negative 5 times 0 is 0. Add, you get negative 2. And negative 5 times negative 2 is 10. Add, you get a remainder of 0. And if you don't get a remainder of 0, then something's wrong. So one of my factors is x plus 5. That's because negative 5 is a 0. Now I've got to find the other ones. This is x squared, no x, minus 2. So I need to figure out what would my other zeros be. So if I solve this, I get x squared equals 2, take the square root of both sides, and I get that x equals the positive and negative square root of 2. So my zeros are going to be negative 5, square root of 2, and negative square root of 2. And those are my three zeros. If I tell you that you've got problem 46, I tell you that f of x equals x to the fourth minus 16, and I tell you that 2i is a 0. Well, if 2i is a 0, so is negative 2i. They come in pairs, and I'm looking for 4 zeros because it's x to the fourth. Let's see if I can find any on my calculator. Go here, and I'm going to put in x to the fourth minus 16, x to the fourth minus 16. Check the table to see if I can find any zeros. And look, negative 2 is a 0 and positive 2 is a 0 from my chart here, negative 2 and 2. So I already know that 2i is a 0 and negative 2i is a 0, and now I know that negative 2 is a 0 and positive 2 is a 0, and I'm looking for 4 zeros because it's to the fourth power, so I am done. Alright, I am going to stop here, and then I'm going to pick up with another video.